So now we've discussed all the various subcortical structures that play a role in memory, and therefore it's appropriate to have a look at the connectivity and functions of the hippocampal system as a whole at this point. This illustrates the connectivity between the cortex and the hippocampus, and the connectivity within the hippocampus proper. But I've added the hippocampal region CA2 to the earlier diagram we were discussing. CA2, like CA3, gets inputs from layer 2 of the entorhinal cortex and projects to CA1, but unlike CA3, it doesn't get any input from the dentate gyrus. So, as described earlier, the dentate gyrus and the CA fields define receptive fields that correspond with large groups of cortical columns that have tended to expand their receptive fields at similar times in the past. There's a competitive process within CA3 and the dentate gyrus to define the most appropriate candidates for receptive field expansion. Once the competition is complete, the results are released to CA1, which drives receptive field expansions through the subicular complex and the entorhinal cortex out into the main cortex. In addition to this basic connectivity framework, there are a number of subcortical loops. Firstly, the hypothalamus sends outputs to CA2 and also the dentate gyrus. It receives a lot of inputs from the subicular complex. In information process terms, it's biasing the selection process within the hippocampus in favor of cortical areas that tend to recommend the currently prioritized type of behavior. The amygdala gets inputs from the subicular complex and the entorhinal cortex, inputs from points on the output path from CA1 towards the cortex. By these points, the CA1 outputs identify very large groups of cortical columns that have been selected for receptive field expansion. Those very large groups have been decoded to somewhat more limited groups, and the amygdala places a bias on any groups located in cortical areas that detect receptive fields able to discriminate between complex social situations. So the amygdala turns up the volume of information recording in those areas. The outputs from the hippocampal system have to be released to the cortex, and as for all releases to the cortex, the thalamus manages the release process by placing the gamma band modulation appropriately on entorhinal and subicular complex outputs. And finally, the septal nuclei get inputs from CA3, and from these inputs can determine when the competition process has concluded. It then imposes the additional theta band modulation to allow release of outputs to CA1 and on towards the cortex. So the hippocampal system as a whole is made up of components located in many of the major anatomical structures. Each component performs a different type of information process that's needed to select and drive appropriate cortical receptive field expansions. And apart from the connectivity, a major reason for viewing this as a single system is that damage to any part of the system tends to result in similar cognitive deficits.